नमस्कार दोस्तों और किड कम लव मैथ्स पर आप सभी को स्वागत है. So what we had been discussing in the last session, the problems related to composite functions. So today again I will discuss some problems related to composite functions. So let's begin the session. So today's question is, here it is. The question is question number 5. And yes, also I would like to tell you that the questions are taken from the book A Class Book of Mathematics by S. Sun. So, if fx equal greatest integer function x and gx equal modulus of x, then find g0 of f of minus 7 by 5 minus f0 g of minus 7 by 5. And the next question is to find g0 f of 7 by 5 minus f0 g of 7 by 5. So, first of all, to solve this question, we have to know what is a greatest integer function and what is modulus function. Here, we are given two functions fx equal greatest integer function x. So, the definition of a greatest integer function, and symbolically it is denoted as this. When we take a function fx and this equals this bracket and here the element x, then it means this function takes the value either less than x or equal x. So the definition of greatest integer function is when a function is equal to greatest integer function, then this means this function takes the value either less than this value or equal this value, but the number should be an integer. We cannot take decimal values, but we should take integer values only. So this is the greatest integer function. And secondly, we have gx equal modulus of x. Gx equal modulus of x. This is the modulus function. And modulus function is nothing but a function which takes value only positive. It takes only positive value whenever it is negative or positive. Suppose we take some example. Let us take fx equal minus 2x. We suppose it as, if this is given, then by definition of modulus function, this negative sign comes out. This negative signs gets positive. That means we should take the value twice x only. Here the negative signs removes. So gx equal modulus of x. This means whether the value of x is positive or negative, but the result will be only positive. So this is the modulus function. So I hope you are getting this. So come to the solution. The number 1 is g0 f of negative g0 f of negative 7 by 5 minus f0 g of negative 7 by 5. We need to find this value. So let's proceed. g0 f of minus 7 by 5 minus f0 g of minus 7 by 5 equals by definition of a composite function, we can write it as g of f of this value. Similarly, this can be written as f of g of minus 7 by 5. I hope this is being clear. It is by definition. By definition of a composite function. Now, here f of minus 7 by 5. What is the value of this? Since we are given that f of x, here x is equal to minus 7 by 5. Since f of x equal greatest integer value x, so we can write it as this is equal to greatest integer value minus 7 by 5. This is from the question. Similarly, f of bracket g of minus 7 by 5. What is the value of this? Because as given in the question, g of x equal modulus of x, so we can write it as f of modulus of minus 7 by 5. Right. From definition in the question. So this is now, as we have already discussed that what is the greatest integer function. So from definition of greatest integer function, it will be equal to what? It will be equal to minus 2. So why it will be equal to minus 2? I will show you here. What is the value nearest to minus 7 by 5 and which is less than or equal to this? The value which is less than to this number or equal to this number. So the nearest less value to this fraction minus 7 by 5 is minus 2, because minus 7 by 5 is nothing but negative of 1 2 by 5. So the nearest less value to minus 7 by 5 is nothing but minus 2. We cannot take fraction or decimal value because greatest integer value, the name in the definition integer, we should take integers only. The integer less than this number or nearest to this number is only minus 2. So here I write here g of minus 2. Similarly, and here the modulus function. Since modulus takes only positive value, so minus 7 by 5 will be equal to 7 by 5 because it is the modulus function. So here 7 by 5. Is it clear? It is from definition only. Definition of greatest integer value and modulus function. Now g of minus 2 is what? The value of the function g at the point minus 2 is equal to the definition of gx equal modulus of x in the question. So by definition in the question, this will be equal to modulus of this value, and this value is minus 2, so modulus of minus 2. And f of x equal greatest integer value x. So here f of 7 by 5, it will be as 7 by 5 greatest integer value. Minus 2, the modulus value of minus 2 will be plus 2, as I have already said. And here greatest integer value of plus 7 by 5, it will not be equal to minus 2 because this is not a negative number, this is positive number, and 7 by 5 equal 1 2 by 5. 7 by 5 equals 1 2 by 5, and now the value nearest to this number, or less than this number will be 1, because this number is 1 is to 2 by 5, but the number less than this number will be 1. So greatest integer value of 7 by 5 will be 1, which is an integer. So finally we get 2 minus 1. So 2 minus 1, 1. So here it is the answer. Z naught f of negative 7 by 5 minus f naught z of negative 7 by 5 is equal to 1. So what we have applied in the question, in the solution, so we have applied the definition of greatest integer function and definition of modulus function. And how this value evaluates, I am showing here. So I hope you are getting it. So this is done. So the next question is z naught f of 7 by 5 minus f naught z of 7 by 5 is what? We have to find the value of this subtraction of these composite functions. So I would like to say you that this is a homework for you, because this is very similar to the first one, and I want you to let me know the answer in the comment section, please. So here are the hints for this question. I'm again repeating. You should apply the definition of this greatest integer function and modulus function in the question. So apply the definition of greatest integer function, apply the definition of modulus function, and also apply what will be the value of greatest integer value of 7 by 5 and the value of modulus of 7 by 5. Then surely you can solve this problem. So proceed to the next question. So the question is, let f is a function from z to z and z is another function from z to z be defined by f of n. The function f is defined as f of n equals 3n and z of n equals n by 3 when n is a multiple of 3, otherwise 0. When n is not a multiple of 3, then this function value is 0. So that z naught f equal iz and f naught z not equal to iz. So z naught f equal iz. Here iz is nothing but identity map. It is, here iz means it is an identity function or map. Identity map. Map means function. We need to show that the composite function of f and z is an identity map while f naught z is not. So for that, first of all, we need to know what is an identity map. If we have a function fx, if fx is a function defined as if f is a function, we cannot take f of x. If f is a function defined as f of x equal x, suppose f is a function from a to b. If we have a function f goes from a domain to a range from a to b, and it is defined as f of x equal x for all x belong to the domain A, then this function is called an identity function or identity map. So whenever we get a function from A to B, if the uh, value of any element equals that value, that element on this, that is fx equals x, that means the function takes the value this for all x belongs to the domain set A, then this is called identity map. So we will apply this in the solution. For that, we need to find the value of z naught f. So the function z naught f, suppose we take an element n and then evaluate this value. Now z naught f of any element n equals z of fn, right? This is obviously because by definition of a composite function, this always implies z of f of n. Now f of n equal what? F of n equal 3n. In the question we are given that f of n equals 3n. So here z of 3n. Again we should apply the definition of z also. The definition of the function z also. Since z of n equals n by 3, when n is a multiple of 3, that means suppose the number 3, 6, 9, 12, etc. or 3 into 8, any multiple of 3. If we have the numbers, the multiple of 3, 3, 6, 9, 12, and so on, or suppose any number which is multiple of 3, 3 into a, suppose a is another number, then this function value will be equal to n by 3, because it is given z of n equals n by 3 when n is a multiple of 3. Since this is a multiple of 3, here 3n is multiple of 3 because 3n is nothing but 3 into n. For any element or any number n, 3n is multiple of 3n. Therefore, by the definition of z in the question, we will get this divided by 3. Since z of n equals n by 3, so here it will be 3n by 3. So I write it here. So here 3 cancels out. The answer is n. So how we get z naught f of n equal n? We get from the definition of composite function, we simplify in the first step z of fn. Again in the question, fn is nothing but 3n, so z of 3n. Again by definition of the second function z in the question, that if this number is a multiple of 3, then this value will be equal to this number divided by 3. So here 3n, if we say 3n is a whole one element, single element, then this divided by 3 because 3n is multiple of 3. So I have already said that if a function takes the value this, if for a function, if the function value is nothing but that value for all values in the domain, that means if f is a function and f of x is nothing but x for all x belongs to A, then this is the identity map. So here we all know that z naught f is a function, because we know and we have already discussed what is composite function. Composite function is nothing but a function made up of two or more than functions. So it is a function. So this function of n is nothing but n. So this is an identity map. And whenever it is an identity map, we always denote it as identity I. Since the function's domain is z, so I use suffix z here. So f is a function from z to z, c is a function from z to z, then their composite function z naught f always goes from this function, this set to this set. So z to z. And the domain of this z naught f is z, therefore I use suffix here. So z naught f of n equal iz. And in the question, we have to show that z naught f equal iz. So here we are done. So the first part of this question is done. I hope you were getting it. So come to the next part. Now we need to show f naught z not equal iz. For that we need to find f naught z, the value of this composite function. So let us suppose f naught z of any element n. So by definition, this is written as f of z of n. Now z of n is nothing but this. In the question, z of n is defined as n by 3, z of n equal n by 3 whenever n is a multiple of 3, otherwise it will be 0 when n is not a multiple of 3. Now f of these two segments, function value of these two segments, it will have two results. It will have two values. First of all, f of n by 3 is what? F of n by 3. This function will have two values. So f of n by 3 will be, since f of n equal 3n, so f of n by 3 will be 3 into n by 3. By definition of this is when n is a multiple of, this is not applied here. So f of n equal 3n, so applying this here, f of n by 3 will be 3 into n by 3, and 3 cancels out, then we get the value n. Again f of 0, what will be the value of f of 0? What will be the value of f of 0? Since f of n is 3n, so f of 0 for any element n equals 0, 3 into 0 also 0. So this function f of two segments, f of n by 3 when n is a multiple of 3 and 0 when n is not a multiple of 3, this function have two results, that one value is 1 and the other is 0. But in the identity map, in the definition of identity map, it is always known that f of x equal x for all x belongs to the domain. But here this function is not a unique solution. This function has no unique solution. This function has two values. One is n and other is 0. So we cannot say that this function is an identity map in the domain Z. So this is not equal to Iz. So I hope it is easily understood. So here f naught z of n is not equal to identity map in the domain Z because this function is not only equal to n but also this equals also to 0. So this is not an identity map. Therefore, this f naught z is not equal to iz. So here is the solution. So take a glance at this. The first one, we have found that g naught f of n equal n only that region. This is an identity map iz, but here f naught z of n is not iz. So we are done with this question. And today's session is only about these two questions. I hope you are enjoying. So hope to see you soon in the next session with a new topic. Till then, take care, bye bye, and thank you for watching.